or switch to self-employed. And so if you're in industry, what I'm saying is 75% of those industry people are going to stay in industry, 15% will switch to government, and 10% will switch to self-employed. Similar things for the other rows. Out of the government people, 60% will stay in government, 30% will switch to industry, and 10% will switch to being self-employed. And a similar thing for self-employed, 40% will stay self-employed, 35% will switch to industry, 25% will switch to government. So that's what I want this table to represent, is the percentages of people that are sort of switching classifications. Okay, switching employment. So what I would like to do is represent this by the transition diagram and then maybe also by the transition matrix. I'd like to see what those should look like. And this is a more complicated example. You know, there's more states now. This time I have 3 states instead of 2. You're either industry, government, or self-employed. And so necessarily our transition diagram will just look a little more complicated than the other examples, but that's okay. So I want to see, where should I draw this? Maybe I'll just give myself a little extra room over to the right and we can draw it there. Let's see, keeping the table. I'll just draw a % sign for percentage. Okay. So let's draw the transition diagram off to the right here. So there are 3 states, so I need 3 vertices in my graph. There is industry, there is government, and there is self-employed. Next, I need to draw on all of the arrows that I can think of for the different transitions. So if I start with industry, it's possible that I started industry and then I stay in industry. So I should draw an arrow from industry to itself. And what should that get labeled with? Well, it looks like that should get labeled with 75%, so maybe 0.75. You know, you might find it convenient to either write in decimals or fractions for a lot of these problems. I don't really care which you use. Just be a little careful when you're converting. If you ever convert from like fraction to decimal or something, be a little careful that you don't chop off decimal points, decimal places. Don't approximate too much. Yeah. So maybe my advice is if it's given to you in decimals, stay in decimals. If numbers are given to you in fractions, stick with fractions as much as possible. Unless you're asked to approximate or something, just to be careful. Anyway, so 75% chance of staying in the industry. I could go from industry to government, and that's a 15% chance. So I draw an arrow from industry to government. That's a 15% chance. And I could go from industry to self-employed, so I should draw an arrow there. And that's a 10% chance, so that's 0.10. Okay, next I'll look at government. What are the odds of you staying at government if you were already at government? That is a 60% chance. Next, I could switch from government back to industry. So I could draw an arrow from government to industry, and that is a 30% chance. I could switch from government to self-employed, and that's a 10% chance. Finally, I need the arrows that come out of self-employed, that start at self-employed. Self-employed back to self-employed, that is a 40% chance. Self-employed to industry is a 35% chance. And self-employed to government is a 25% chance. So this is my transition diagram for this situation here, for this Markov chain. Okay. Cool. And so if I wanted to answer any questions about this, I'd have to trace out paths. And maybe they could get more complicated just because I have more states that I could possibly be in at a given time. So next, now that I have this transition diagram, I'm going to erase this table. And let's write down the transition matrix just so we have it. Just so we get used to writing these down. What would the transition matrix look like? How big should this matrix be? This matrix should be a 3 by 3 because I have 3 states. So however many states you have will tell you how big the matrix should be. It'll be a square matrix with that many dimensions. So this is a 3 by 3. I have an industry, government, self-employed, industry, government, self-employed. So industry to industry was 0.75. Industry to government was 0.15. Industry to self-employed was 0.10. Government to industry was 0.30. Government to government was 0.60. Government to self-employed was 0.10. And self-employed to industry was 0.35. Self-employed to government was 0.25, and self-employed back to self-employed was 0.40. So this would be my transition matrix here, this 3 by 3 matrix. Okay. Okay, and so again, we can answer questions by tracing out paths. I think I'm gonna not do that at the moment. So one last thing I'm gonna do, and okay, before I do that, let's pause and ask, are there any questions at this example? Or concerns or anything? Okay, well, okay, so this is this example here. I've set up the transition diagram and the transition matrix for this example. So we should, if we want to be real careful, again, we should notice the rows all add up to 1. You can check that yourselves. They certainly do add up to 1. So this really is a transition matrix. So what I want to do is one more example where I'm just going to give you a transition diagram. Or maybe it'd be more interesting to give you the transition matrix first, and then write down the transition diagram for it. Maybe we'll do it that way. I was going to do it the other way, but let's switch it up. So let's say we're given a transition matrix. What is the diagram? So when you have a new concept or an object that you have to understand, it's good to ask these kinds of questions. We just spent a couple examples where we already had the diagram and then we got the matrix. What if we want to go the other way? What if I have the matrix? How can I get the diagram out of it? It's just good to check our understanding that way. So let's do one of those. Let me give you a matrix, a transition matrix. So I need to put numbers in it, and I need to make sure that the rows add up to 1. That's a transition matrix. So how about this? Let's do the following. About 0.3, 0.2, 0.5. How about 0? How about 1? How about 0? And how about 0.5, 0.1, 0.4? Okay. So this is going to be the matrix. Let's find the corresponding transition diagram for it. And to do that, I'm going to give names to my states so I know which state is which. So how about there's state A, there's state B, there's state C. That's A, B, C. Just some generic names so I could write down a diagram of labels. And then these numbers are supposed to represent the probabilities of transitioning from one state to another. What's going to be weird in this example are these zeros. We haven't seen any zeros yet. And so I want to think about what that is going to mean. If that's like weird or something. So let's go ahead and write down my vertices. I should have 3 of them because I have 3 states. There's A, there's B, and there's C. So now I need to fill in the arrows from each one, connecting them, corresponding to this matrix. I'm told from the matrix that the probability of going from A to A is 0.3. So I need an arrow from A to itself that has a label of 0.3. And the probability of going from A to B is 0.2, so I need an arrow from A to B. That's 0.2. And I'm going to need an arrow from A to C. That's 0.5. So far, this is my diagram. Okay, next, I'm told that the probability of going from B to A is 0. So if I'm at B, there's no chance that I will go. It's basically completely not going to happen. That's not quite right, but let's just say this. The probability of going from B to A is 0. So it's statistically unlikely, statistically impossible that I will do that. So on the one hand, I could draw an arrow from B to A and label it 0, but that kind of feels silly because, it's 0. It's basically not going to happen. I'm not going to go from B to A. I'm sort of not allowed to go from B to A. So instead of drawing an arrow and labeling it 0, how about we just don't even draw an arrow? And we just skip that. Yeah? So we just won't even draw an arrow from B to A because this probability is 0. Okay. So this is a good point to point out that if you're trying to write down a matrix from a transition diagram, or if you're drawing a transition diagram from a matrix, either way, if you're missing an arrow from one to another, that means that the probability of going from that state to the other state is 0. So the fact that I'll be missing an arrow from B to A means that this probability B to A is 0. That's just something to point out. You may see examples when you guys are doing your homework or activities where you have diagrams that are missing arrows, so to speak. And that means that the probability, there's some probability in there that's 0, is all that means. Okay. Okay, so the probability of going from B back to B is 1. Okay, and then the probability of going from B to C is also 0, so there's no arrow from B to C either. Okay. And then finally, there's an arrow from C to A with a 0.5. There's an arrow from C to B with a 0.1. And there's an arrow from C to C with a 0.4. And so this is my complete transition diagram from this. So it looks different from the previous ones because it's missing some arrows, right? I don't have an arrow from B to A, and I don't have an arrow from B to C. But this is fine. This is how it goes. So one thing to point out about this kind of situation is, you know, you could see yourself following paths where you sort of get stuck at B. You know, I could start at A, and I could go around here and down here and come over to B. But once I get to B, I have no way to go to other states. I am forever trapped at B because there's only this arrow that comes out of B, but it goes right back to B. You know, you have to follow the directions of the arrows. There are no other arrows going back to A or C, so you're stuck at B forever. Once you get to B, you're stuck. So if I were to ask you, like, what's the probability of starting at B and then transitioning over to C after 10 steps or something? Well, that's easy. The probability is 0 because it's impossible for me to get from B to C. So here's a situation where some of the probabilities are easy to compute. Because if I ever ask about transitioning from B to something else, it can't happen. I'm stuck at B forever. There are no paths from B to the other states. Thus, the probability of going from B to A or from B to C after however many steps you want has to be 0. So these kinds of things can happen once you start leaving arrows off. Or you might get stuck in certain states. Okay. Cool. So that's it for this example here. I just wanted to show a weirder example of a transition diagram and how it related to the transition matrix. Okay, so I think that's all I want to say today. I might have a little more to say tomorrow about these, maybe some more examples or something. But so I'm going to leave it at that for today. If you guys have any questions,